The counter of Hadi's Cafe is manned by a single employee, and customers need to place their orders and make payments at the counter. The process of placing an order and making payment usually takes 5 minutes, which keeps the counter busy and results in longer wait time for customers. 2 customers are expected to arrive to Hadi's Cafe every 12 minutes. According to the arrival rate follows Poisson distribution, while the service rate follows exponential distribution. Hadi, the owner of the cafe, is beginning to realize that he has many people to serve, but only have one counter, and he is unsure what to do. Will it be beneficial to install another counter in my shop? Currently, I pay my staff 9 ringgit per hour while bearing the cost of customer waiting at the cafe for 3 ringgit per hour. However, Hadi appears to have a solution to these issues in his mind, which is quite surprising.
It appears that owner cafe have a problem. Is it worthwhile to add one more counter at the cafe? So we start with find the total cost for one counter as equal to 1. Before we start, we must know mean arrival rate. We know 2 customers arrive for 12 minutes the average. So the average will be 10 customers for 60 minutes. Then mean service rate. The counter can handle one order for 5 minutes. So it will be 12 orders for 16 minutes. For total cost, we must know the average number of customers in system L. We input the lambda and mean in the formula and we will get L equal to 5. Then we find the average time of customers spent in system W. Same, we put the mean and lambda and we will get W equal to 1 over 2.
The probability the service facility is busy, P is equal to 5 over 6, while the probability that a customer can be served P naught is equal to 1 over 6. Therefore, the total cost for one counter is 24 ringgit. The owner is considering adding one more counter and hiring one more person. Therefore, we need to apply a multi-channel queuing model. The number of channels is S equal to 2. Lambda is equal to 2 customers per 12 minutes. Therefore, we need to multiply by 5 equals 10 customers per 1 hour. Mu is 1 order per 5 minutes. Therefore, we need to multiply by 12 equals 12 orders per 1 hour.
So first we need to find P, which is the probability the server is busy. So to find P, we need to divide lambda with S times mean. 10 divide 2 times 12 equals to 5 per 12. So we will use P to find the probability 0 customer in the system. P0 equals to 1 per sigma 1 per n factorial times lambda per mean power of n from n equals to 0 until n equals to 1 plus 1 per s factorial times lambda per mean power of s times 1 per 1 minus p. So lambda equals to 10, mean equals to 12, s equals to 2 and p equals to 5 per 12. The P0 equals to 7 per 70 or 0.4118. Now we will find the average number of customers in the queue. LQ equals to P times lambda per mean times P0 divided by S factorial times 1 minus P square. Lambda equals to 10, the mean equals to 12 and the S equals to 2. So the P0 we will use the value from before 7 per 70, and after we insert the value we will get 125 per 714. or 0.1751. After that, we will find the average number of customers in the system. L equals to LQ plus lambda per min. LQ equals to 125 per 714. Min equals to 12 and lambda equals to 10. After insert the value, we will get 120 per 119 or 1.0084. Lastly, we will find the average time a customer spend in the system. W equals to L per lambda. L equals to 120 per 119. Lambda equals to 10. After insert the value, we will get 12 per 119 or 0.1008. Then we will find the total cost equals to SCS plus lambda WCW. S is 12, CS is 9, which is cost server. Lambda equals to 10, W equals to 12 per 119, and CW, which is cost waiting, equals to 3. After we insert the value, we will get RM21 ringgit and 3 cents.
Hadi successfully solved the problem, and he has decided that it is worthwhile to add another counter. Then he hires a fresh employee to work with him as a counter 2, with the total cost of 21 ringgit and 3 cents. Now, he has extended his cafe by adding 2 counters and 2 employees. The average length of time that the customer spends in the system decreased from 30 minutes to 6.3 minutes.
In the conclusion, it is worthwhile to add one more counter to Hadi's cafe because the total cost for 2 counters is less than the total cost for 1 counter. The total cost for 1 counter is RM24 ringgit and the total cost of 2 counter is RM21 ringgit 3 cents.
What's the takeaway from the story? Queuing theory is a useful tool for reducing waiting times, and when waiting is unavoidable, businesses can create a positive customer experience. Thanks for taking the time to watch the video.